Hi everybody, welcome back on MakeIT. I'm sorry for the delay since my previous video. It was because I got exams, I got an internship, so I was really busy. But today I'm back and we're going to talk about how to deploy a SciKit-learn machine learning model onto an ESP8266, as you can see here. So this is quite tiny, so tiny machine learning. You get an accelerometer and we will classify if the USB connector is up, horizontal, or down. This is quite simple and not really interesting, of course, but it's to give you the tools and the keys to understand and how to do it simply. You will see that SciKit-learn is a simple machine learning library in Python. You will see the code is really short. And also in the C++ part, Arduino part, you will see that you don't have to include a lot of libraries and this is simple to use. You'll see that. I hope you will enjoy it. And so let's go to see the pipeline. Okay, so here's a tiny machine learning pipeline customized with SciKit-learn. First thing you need to do is to identify your need. This is a major part, for me, the big deal. It's really important to do it. So today, we want to classify the orientation of USB connector, okay? So this is our need. We want to classify it. I really insist on that word. To do it, we need to find data. So to find data, you can use your own sensors or find it on Kaggle or dataset search. But I've created my own dataset using my software datasets builder available on GitHub, and I've shown you this software in my previous video. I really encourage you to look for it, okay? And so I've used this board and this accelerometer to capture some data with this example, this and this, okay? Once we've got our need and our data that will respond to our need, we need to create a model and train it and evaluate it. So to do it, we'll use SciKit-learn. This is a really simple and easy to use library to do machine learning, okay? This is more about machine learning, not deep learning, okay? This is quite about statistics. And we'll also use Google Collaboratory, which is a notebook, okay? But you can use Python. After that, we have a model in Python. We have to convert it into C code, so that can be understood by the board. And after that, in blue, this is a fun part, and we deploy it on board and make some prediction and make a lot of fun. To do it, I will use Visual Studio Code and Platform IO, but of course you can use Arduino IDE. So the next step, I'm going to show you the notebook where I can process data, create a model, train it, evaluate it, and convert it into C code. Let's go to do it together. Well, this is a Google Collaboratory notebook. First thing you need to do is to import all the libraries. First, Pandas, which is a library that allows you to load the data and process it a bit. NumPy, it's a library that provides us some features for arithmetical operations on our datasets. We'll use train test splits, which is a module from SciKit-learn that allows us to split our datasets into a test set and a trained set, and the test set will be used to evaluate our model. This will be unseen data. And we will also use SVC, which is our classifier, to classify our data. And also you have to drag and drop or upload your file, which is called orientation.csv. Okay, you run it. After that, I have to load the data by providing the path and the separator of my file, comma separated file. And let's see the 5 first rows of this data frame. So as you can see, we have XYZ column, that accelerometer on the 3-axis, and the label, so orientation here is down, but you also have, if you run it, other labels. So you have horizontal, up, down, and you can see the number of records for each label. It's not the best way to do it because we have much more horizontal record than down record, so that's not the optimum point, but that will work. You will see later on. Data are loaded. We have to refine our datasets. So as you can see, we have literal labels and you have to convert it into numerical labels. So we'll do it by using a method orientation to number, okay? This is quite explicit. You provide X and you return the corresponding number, and we'll use apply on this column that allows us to apply this method on each element of this column. Let me simply run it and you will see the results. We're done mapping, so as you can see, down is 2 and we have 2 as down here, okay? So that's working. Everything is numerical, so as you may know, machine learning only took numerical values, so that's great. Data are cleaned, and the final thing you have to do is to convert it into NumPy array to be processed by the model, and we extract the labels and the features. So let's see what it looks like. Okay, you have labels, the class, and the features here. So here is record for X, Y, Z. After that, we have to, as I explained to you before, we have to split our dataset into two parts. 15% will be dedicated to a test set, 55% to a train set. So we'll train on the train set and we'll evaluate the accuracy of our model on the test set. Well, that will be unseen data. This is a quite useful tool. Great. Okay, so we are on the model building part. We have to instantiate our model, which is an object, as we see with this value. So this value is completely random. Okay, so I followed a small tutorial and they told me that to use these values. I'll assign it into model, okay, variable. We'll fit this model on the train set. So here is the trained features and train labels. Let's simply run it. It's quite quick, as you can see. We have to evaluate our model. So as you can see here, we will model the score on the test features and test labels. So this method will make an inference on the test features and compare the results to the test labels. So that will create a simple score and we'll print it out. So let's run these cells and you will see that we have 100%. So it's quite accurate, as you can see. Of course, it's easy because when you look at the board, it's easy to look that this position is quite different than this in this position. The positions are really extremely far from each other. It's quite good. This is what we want, but of course you have probably other configuration that don't match it, so we not have 100%, but here we are happy. And now we are ready to convert our model into a C file. To do it with SciKit-learn model, we have to install microMLgen, okay, using pip. So let's run this command. Okay, now microMLgen is installed. Import port from this library. Okay, this is a module. One big features and really interesting and important features from port is that you can specify a class map. So class map is a dictionary that map each number. So as you can see here, each number, so 1, 2, or 3, to each corresponding class. Okay, so we'll do the inverse work by defining this class map. So let's run this command and you will understand what it is. So this is a dictionary, so you know that 0 corresponds to up, 1 to down, and 2 to horizontal. Okay, this is quite useful and you have to provide it into the call of port. To port you give model and the class map, but you can also add the platform you use. Here is Arduino by default, but if you use, I don't know, STM32 or other, you can specify it here. Then here I convert the code into a C++ code. I write it into a .h file, and after that I will evaluate and print the site in bytes to verify that it could be stored into our board. Quite quick, so let's refresh it. And we have our model.h. This is, you will see later, but this is a C file with a lot of maybe loops and if, and you will see. We will predict using this file. As you can see, the size here is big, but it could be stored into an Arduino, so that's good. We only have to store it into our board, so let's go and go to Visual Studio Code and the C++ code. Okay, so here is the C++ part. So the IDE I will use is Visual Studio Code, as always, with Platform IO. This is an IDE and an environment that provides you some SDK and project manager to create your own Arduino project. Okay, this is really useful and supports a lot of boards and libraries. It's an extension that you can download from this extension on the right side. Here we'll code together. First, create a project, make it underscore SciKit-learn orientation spot. Okay, we'll use a Wemos D1 Lite. Okay, and we will store it into another location. Let's click on finish and the project will be created. Okay, that's take some minutes. Well, here is project created. Okay, let's close this window. You have to open main.cpp. This is our main part and we'll code all the C++ here. Before that, you have to include in the include folder the model.h file that we have downloaded from Google Laboratory. Okay, so here is the model.h file. As you can see, this is several namespace with a class SVM. This is our classifier. We have a lot of methods, as you can see. I will shorten to make it more real. And we'll use predict label. So this method we input x, so that will be an array containing our 3 XYZ position from accelerometer, and we'll predict the label for this class. So I let you read. As you can see, this is due to our class map, okay, that map number to class. You can change it if you want, okay. And here is a big method predict that will compute with all learned from our data. Just close it. To include it to our main.cpp file simply include model.h, maybe in quotes. Let's save it. To use it, we have to use our accelerometer here. This is MakeIT that function in I2C protocol. So to use it, we have to include two libraries from Adafruit. Open PIO Home to download libraries or to include it into our project. Okay, so libraries. We have to look for MakeIT Adafruit MakeIT. Add this to our project. Okay, add it, and we have to load another library to use Adafruit sensor. Okay, so this library is called Adafruit sensors. It is quite obvious. Great. And now search Adafruit sensors, unified sensors. The header. This is the file we want. So add it to our project. Select the right project and add it. Great. Let's close PIO Home, return to our project. We need to include Adafruit MakeIT and include Adafruit sensors. Right. We need to open this file. Okay, very good. Here, instantiate Adafruit underscore MakeIT object. We'll call it accelerometer. Okay. Then instantiate our classifier using elocant. Let me look for the namespaces. So elocant ml port svm, elocant ml port svm, and we'll call it svm SciKit-learn classifier. Okay, is the name of our classifier. Great. Sorry, I've forgotten, because this sensor works with I2C protocol. We have to include wire.h library to use I2C protocol. Okay, instantiate serial that begin, because we use ESP8266, we'll use this baud rate. It's quite quick. Begin wire. Okay, and we'll also begin accelerometer. Okay, and if not, error with MPU. Okay, double quote, better. Then we'll print that everything is set up. Everything is set up, and in the loop method that will run repeatedly, we have to first thing read the MPU to get accelerometer data XYZ. Okay, so to do it, we have to create an object called sensor events t, and with a, which is accelerometer, j gyroscope, and temp for temperature, because these sensors is not only an accelerometer, but it's also a gyroscope and temperature sensor. To store this data to our variables, we have to call this method get event. Okay, with pointer of the memory and temp. Okay, like this, right? And we'll simply create float features equal to, this is an array of 3 elements, so XYZ. Open curly braces, and you can call A, which is acceleration.x, and do the same thing for Y and Z. Okay, this is our input, and string output str equals classifier dot predict label from features. Okay, and let's print serial.println only output string. Okay, let's put a delay. We'll put 7,700 milliseconds. Okay, so as you can see, the code is really short. You don't have to begin the classifier. This is only hard-coded, so we only have to call our model and to begin serial communication and I2C protocol to use our sensors. Sorry, I've forgotten beginner error. Let's plug our board and upload the code. Okay, it's almost done. Great. So it's compiled and uploaded without any errors. Let's monitor the results. I simply click on reset once loaded. Okay, so as you can see, the connector is down and it went down, horizontal, okay, and up. So it's working. As you can see, it's really working nice. So I'm quite happy. So this is a simple project, not really interesting, but Of course, it's to give you the tools and the keys to understand how to deploy a end-to-end project from data to MCU here, and using a SciKit-learn model, which is a really weightless library and really easy to use library compared to TensorFlow. So for those who are starting machine learning and don't want to use TensorFlow because it's too complicated, you have to convert code and you don't want it, just use SciKit-learn and you can do it really simply. So as you can see, 30 lines and quite easy. And so if you get any question, feel free to ask in comments. If you have any other query, don't hesitate to reach me, okay? And for the next video, I don't know yet, but maybe to use a TensorFlow JS, so JavaScript model, stored into ESP8266, so to classify images into a web page stored into ESP8266. Okay, so that's quite complicated and the video will be a bit long, I think, but maybe this, or maybe create some API using Flask to deploy a model into a backend or API. So I don't know yet, but one of those tutorials. So I hope you have loved this tutorial, and if you got any question or query, don't hesitate to reach me and I will answer you. Bye.